Through our discussion of arrays, we learned how to store multiple values of related data in an ordered fashion under one variable name. And now that we can do that, it would be really useful if we could step through this array one element at a time and access or manipulate that data. We can in fact do this manually. Let's say, for instance, we found out our thermometer measuring temperature was off by 1 degree, and we wanted to come in and add the value 1 to each element of the array. We could reference temperatures 0 equals temperatures 0 plus 1, and then we could say temperatures 1 equals temperatures 1 plus 1, etc., etc. But this is already tedious, and if we had thousands of values in this array, it would just be impractical. It would be better to write a segment of code that would repeat itself, stepping through the array one item at a time. And we can do this with what is called a loop. And the first loop we're going to talk about is a while loop. And the while loop will execute a body of code enclosed in curly brackets while a certain condition enclosed in parentheses is true. So in this example, we want to take temperatures at each position and add 1 to it. But we need a way to reference that position. So we're going to add another variable. We'll call it I, and we'll set it equal to 0. So we can reference temperatures at position I, and then with each execution of the loop, we can increment I. And I'll do this simply by saying plus plus, which just adds 1 to the value I. Now, in order to complete this, we need to fill these parentheses with a condition that tells the loop when to stop executing. And since we already have this value I, and we know how many values are in the array, we can say while I is less than 5. So let's step through this. When we get to the loop, we're going to check if I is less than 5. Currently, I equals 0, so we will execute the body of the loop. We will reference temperatures in position 0 and set it equal to that position plus 1. We will then increment I by 1, so now I is going to equal 1. And we'll check if I is less than 5. 1 is less than 5, so we'll execute the loop again referencing and setting a certain position to itself plus equals 1, and then we'll increment I again. I will equal 2, we will execute the body, I will equal 3, we'll execute the body, etc., etc., until I equals 5. 5 is not less than 5. So once we've reached this point, it will not execute the body, and it will move on to the rest of the program. So in this example, we create the array temperatures, and position 0, or index 0, is equal to the value 0. We then use this loop to add 1 to each value, and then we're going to output position 0. So when we compile and execute this program, we get the value 1. Now you have to be careful when you're using loops. Let's say, for instance, I had forgotten to put in the statement to increment I. Well, we would hit the while loop. 0 is less than 5, so it would execute the body, but it doesn't change I at all. So when we come back to the top of the loop, 0 is still less than 5. It will execute the body, and then 0 will still be less than 5. And this will enter what is called an infinite loop. And I can compile this, and I can run it, but it will just continue running forever and make my processor get very hot. So I have to manually stop that with Control-C, and I have to edit my loop so that it includes some statement so that eventually this parameter results in false. Now there's a similar loop we can use called the do-while loop. Largely its structure is the same. We will say do, a section of code in curly brackets to execute, and then while I is less than 5. And this code is largely exactly the same, the difference being that this is guaranteed to execute once. So again, we declare our temperatures, we set the variable I, it says do, so it executes this body of code, and then it checks the while statement. Since 0 is less than 5, it'll jump back and do the looping process. The important difference here is that the do while loop will execute the body once guaranteed. Now the last loop I want to talk about is very different from these two. It is called the for loop, and it solves a problem that exists in both the while and do while loop. That is this extraneous variable and this statement here. In fact, this statement here, along with this superfluous variable here, is used so often that there exists a loop specifically for it. It is called the for loop. So I can get rid of all of this, and I can just say for, and I can declare my I variable directly in the loop statement. So I can say int I, then give the condition, I is less than 5, and then I plus plus, and I need to set it equal to 0. Then I can give my curly brackets, and I can say temperatures I equals temperatures I plus 1. So the for loop does largely the same thing, but it allows us to declare our variable and increment our variable and set our condition for the variable all in the statement of the loop itself, which prevents us from needing to have an additional line down here incrementing the variable, and an additional line up here declaring that variable. So the for loop is a convenient way to put all of those commands into a single line of code. However, there is a practical reason for doing this as well, and that has to do with the computer's memory. So if I declare I up here, that's not the right syntax, but you get the point, then this variable I exists for the duration of the program. So some amount of memory is used storing my I variable for the rest of this program. However, by declaring it in the for statement, it only exists within this block of code. Once the for loop is done executing, my I variable stops existing, thus freeing up that memory to be used later. So in addition to being a convenient way of writing code, it's also an efficient way of executing code. So if this video was useful for you, please leave a like. It helps me grow the channel and it will help other people find the video. And again, if you would like to see these tools used in a broader context, I recommend checking out my Developer Diary series, where I am working long-term on big projects and actually putting these tools to use. So thank you for watching. I hope you learned something, and I will see you in the next one.